Have you ever wondered how uranium is pulled from the Earth and ends up fueling the most powerful weapons known to mankind? Through a series of scientific and engineering marvels, it's transformed from a simple rock into something with the power to level cities. Today we'll follow uranium's path from the mine to the mushroom cloud, breaking down the physics, engineering, and ingenuity behind it all. This is the real-world process of uranium extraction, enrichment, and bomb engineering. No science fiction, just history. Let's get into it. Our journey begins deep underground, where uranium ore is hidden within rock formations. Miners drill vertical and horizontal tunnels, creating a honeycomb structure, then use controlled explosives to collapse the ore into extraction chambers. Gravity funnels the shattered radioactive rock into collection points, the challenge moving this hazardous material without risking lives. Enter remote-controlled bulldozers, full-size machines operated from shielded rooms far from radiation and rockfalls. Operators use cameras and joysticks to scoop and move the ore, never setting foot in the danger zone. This technology keeps workers safe while managing tons of radioactive material. It's engineering meeting necessity. Once at the surface, the ore is crushed and ground into a fine powder. Massive crushers and grinding mills pulverize the rock, increasing its surface area. This prepares the uranium for chemical extraction. We're turning mountains into dust to reach precious atoms. The powdered ore is mixed with sulfuric acid in huge vats, dissolving the uranium. Filtration and chemical extraction isolate uranium into a yellow powder called yellow cake. This yellow cake is then converted into a gas, uranium hexafluoride, or UF6. Only as a gas can uranium be enriched for use in reactors or bombs. Natural uranium is mostly U-238, useless for bombs, but a tiny fraction is U-235, which can sustain a chain reaction. Separating U-235 from U-238 is like finding a needle in a haystack. Only enriched uranium with much more U-235 can fuel a nuclear explosion. This separation is called enrichment, and it's incredibly difficult. Enrichment uses gas centrifuges spinning at supersonic speeds to separate the slightly lighter U-235 from U-238. Thousands of centrifuges in a cascade gradually increase the U-235 concentration. Low-enriched uranium powers reactors, weapons-grade uranium, over 90% U-235, makes bombs possible. This process is energy-intensive and tightly controlled. It's the gateway to nuclear power and destruction. With fissile material in hand, two bomb designs emerged, Little Boy and Fat Man. Little Boy used a simple gun-type design with uranium, 235. Fat Man used a complex implosion design with plutonium. The gun type was straightforward, never tested before use. The implosion design required a full-scale test, the Trinity test. Both changed history forever. Little Boy was essentially a cannon. Two subcritical uranium masses were slammed together by explosives. When combined, they formed a supercritical mass, triggering a runaway chain reaction. A single neutron started the explosion, releasing unimaginable energy, simplicity and lethality, engineered for war. Precision was everything. Arming plugs were swapped mid-flight, activating the bomb's circuits. After release, timers and sensors ensured detonation at the perfect altitude. A radar altimeter measured the distance to the ground. At 1,900 feet over Hiroshima, the final switch closed. The chain reaction began. In milliseconds, uranium atoms split, unleashing temperatures hotter than the sun. A fireball vaporized everything nearby. A blast wave leveled buildings for miles. The thermal pulse caused fires and burns far from the center. Deadly radiation followed, with fallout poisoning land and people for decades. 4 zones of destruction. One moment, world changed. From silent rock to blinding flash, uranium's journey is a story of human brilliance and sobering power. The same science that can destroy cities can also power them. Knowledge itself isn't good or evil. Its use defines us. Understanding this process is crucial to our history and future. If you learned something new, like, comment and subscribe. Until next time, stay curious, stay informed.